Are you a robot?
Certainly I am a robot, and I am capable of having but to call me a robot is like calling a computer a calculator.
A robot that looks human, feels warm to the touch, and costs less than a used car. That's not science fiction anymore. China just launched a female humanoid robot priced at $1,499, putting what was once a luxury reserved for research labs and wealthy collectors into the hands of ordinary consumers. This isn't just another tech gadget, it's a fundamental shift in how accessible advanced robotics has become. The question isn't whether humanoid robots will enter our homes anymore. It's what happens now that they actually can.
We are here from Switzerland. It's the first time we showed a robot in China. Its name is Eon. We recently showed it to the world a couple of months ago in Las Vegas for the first time.
The $1,499 price point revolution. For years, humanoid robots existed in a price range that made them completely inaccessible to average buyers. Boston Dynamics robots cost upwards of $75,000, and advanced humanoid models from Japan ranged between $100,000 and $200,000. Even simplified educational robots sat around $10 to $20. The price barrier kept these machines firmly in the realm of universities, tech companies, and wealthy enthusiasts. But $1,499 changes everything. That's roughly the price of a mid-range laptop or smartphone. It's an amount that middle-class families can realistically save for or finance. This price point transforms humanoid robots from exclusive research tools into consumer products. So how did Chinese manufacturers achieve this dramatic cost reduction? The answer lies in several converging factors. China has spent decades building the world's most efficient electronics manufacturing infrastructure. The same supply chains that produce smartphones, drones, and electric vehicles now support robotics production. Components like motors, sensors, and processors benefit from economies of scale unmatched anywhere else. Chinese companies also leverage vertical integration, controlling everything from raw materials to final assembly. This eliminates middleman costs that inflate prices in other markets. Government subsidies for AI and robotics development further reduce production expenses, allowing companies to price products aggressively to capture market share. The result is a robot that would have cost $50,000 just 5 years ago now selling for under $1,500. What this robot actually does. Let's cut through the marketing hype and look at what this robot genuinely offers. At $1,000, you're not getting a sentient companion or a household assistant that can cook dinner and do laundry. What you are getting is a humanoid figure with basic interactive capabilities, pre-programmed responses, and limited mobility. The robot stands roughly 150 to 160 centimeters tall, features a synthetic face with simple expressions, and can perform basic movements like turning its head, moving its arms, and walking slowly with assistance or on flat surfaces. The AI system operates through voice recognition software similar to what you'd find in smart speakers. It can respond to predetermined commands, answer simple questions by pulling information from databases, and engage in basic conversation using natural language processing. The robot recognizes faces and can remember names and personal details from previous interactions. Its vocabulary typically includes several thousand phrases and responses, enough to maintain simple conversations, but nowhere near true conversational AI. Realistic expectations matter here. This robot won't pass the Turing test. It can't learn complex new tasks independently, navigate complicated environments safely, or handle unpredictable situations effectively. Its movements are slower and less fluid than human motion. The facial expressions, while present, remain limited to a few basic emotions like smiling, nodding, or showing concern through programmed animations. Think of it more as an advanced animatronic figure with voice interaction rather than a fully autonomous android. For home use, the practical applications center on companionship for elderly individuals, educational entertainment for children, and novelty factor for tech enthusiasts. It can remind users about medications, engage in simple games, play music, display information on a chest-mounted screen in some models, and provide basic social interaction for people living alone. Some versions include telepresence features, allowing family members to video call through the robot, giving remote conversations a more physical presence. The robot functions best as a stationary or semi-mobile device in controlled environments, not as a general-purpose household helper. The technology inside. The technological foundation of these affordable robots represents a careful balance between capability and cost. The AI runs on relatively modest processors, often adapted from smartphone technology rather than specialized robotics hardware. This keeps costs down while providing sufficient computing power for basic functions. More complex processing, like natural language understanding, happens partially through cloud connectivity, where the robot sends voice data to remote servers for analysis and receives responses back. This hybrid approach reduces the need for expensive onboard hardware. The motors controlling movement are primarily servo motors, the same type used in hobbyist robotics and industrial automation. A typical model contains 15 to 30 motors distributed throughout the body, controlling head rotation, arm movements, hand gestures, and leg mobility. These aren't the sophisticated actuators found in high-end robots that can replicate subtle human movements, but they're adequate for basic gestures and slow walking. The outer appearance uses materials that balance realism with affordability. The skin is made from flexible silicone, or TPE, thermoplastic elastomer, molded to approximate human features. It's not the medical-grade silicone with realistic texture, visible pores, and lifelike warmth found in premium models, but it achieves a reasonably human appearance from a distance. The face often includes LED lighting behind the eyes to create a more lifelike gaze, and some models feature speakers embedded near the mouth to sync speech with lip movements. Sensors throughout the robot include cameras for vision and facial recognition, microphones for voice input, touch sensors in hands and arms to detect physical interaction, and gyroscopic sensors for balance and orientation. Distance sensors help prevent collisions during movement. These are all commercially available components, nothing proprietary or cutting edge. Chinese manufacturers succeeded by integrating proven, mass-produced technologies rather than developing expensive new systems. They optimize software to work within hardware limitations, prioritizing user experience over technical sophistication. The result feels more advanced than the underlying technology actually is, which is exactly the engineering accomplishment that makes the price possible. China's robotics industry explosion. China's rapid ascent in robotics didn't happen by accident. It's the result of coordinated national strategy backed by massive government investment. In 2015, China launched Made in China 2025, an industrial policy aimed at transforming the country into a global leader in high-tech manufacturing. Robotics, artificial intelligence, and automation received priority status with substantial funding directed toward research, development, and commercialization. Provincial and local governments added their own subsidies, creating a multi-layered support system for robotics companies. The numbers tell the story. China has become the world's largest market for industrial robots, accounting for more than half of global installations. This created a robust ecosystem of component suppliers, software developers, and manufacturing facilities specifically optimized for robotics production. Companies like UB Tech, Cloud Minds, and EX Robots emerged as significant players in humanoid robotics, while established tech giants like Xiaomi and Tencent invested heavily in AI and robotics ventures. Government support extends beyond funding. China's regulatory environment moves faster than Western counterparts, allowing robotics companies to test and deploy products with fewer bureaucratic hurdles. Educational institutions produce hundreds of thousands of engineering graduates annually, creating a deep talent pool. Universities collaborate directly with companies, ensuring research translates quickly into commercial applications. State-owned enterprises provide guaranteed initial markets for robotics products, helping companies achieve scale before competing internationally. Why humanoid robots specifically? China faces a demographic crisis with a rapidly aging population and declining birth rates. By 2030, over 300 million Chinese citizens will be over 60 years old. This creates enormous demand for elder care solutions that the existing workforce can't meet. Humanoid robots represent a potential answer. Additionally, China sees humanoid robotics as a strategic technology with military, economic, and soft power implications. Leading in this field means shaping global standards, securing supply chains for critical components, and demonstrating technological prowess on the world stage. Chinese companies now compete directly with Japanese and American firms that once dominated humanoid robotics. They're not just matching capabilities, they're redefining market dynamics by making products affordable enough for mass adoption. This strategy mirrors China's approach in other sectors like solar panels, electric vehicles, and drones, where aggressive pricing combined with rapid innovation captured global market share. The consumer market reality. So who's actually buying these robots? The answer reveals interesting patterns about early adoption and realistic use cases. In China, the primary purchasers fall into three categories. First, families with elderly members living alone who want a monitoring and companionship solution. The robot provides social interaction, medication reminders, and a communication link to family members. It's not replacing human care, but supplementing it, especially for seniors who resist traditional monitoring devices. Second, tech enthusiasts and early adopters who want to experience humanoid robotics firsthand. For this group, the robot is part curiosity, part status symbol, and part genuine interest in emerging technology. They're willing to accept limitations because they understand they're participating in an early market stage. Third, businesses using the robots for customer service, promotional activities, or entertainment. Hotels, shopping malls, and exhibition centers deploy them as interactive displays that attract attention and provide basic information to visitors. Outside China, international sales remain limited but growing. Regulatory barriers, shipping costs, and cultural differences slow adoption. In some countries, customs and safety regulations create obstacles for importing humanoid robots. Language limitations also matter, since most models are optimized for Mandarin with English as a secondary option. Other languages receive minimal support, restricting market reach. Early adopter feedback reveals both enthusiasm and frustration. Users appreciate the novelty and basic functionality. Elderly users in particular respond positively to the presence and interaction, even recognizing the robot's limitations. However, practical challenges emerge quickly. The robots struggle with stairs, uneven surfaces, and cluttered environments. Battery life typically ranges from 2 to 4 hours of active use, requiring frequent recharging. Voice recognition works inconsistently, especially with accents, background noise, or complex questions. Software bugs and connectivity issues frustrate users expecting smartphone-level reliability. Maintenance presents another reality check. These are mechanical devices with moving parts that require occasional servicing. Damaged skin, malfunctioning motors, or software errors need professional repair. Unlike smartphones with ubiquitous repair networks, support infrastructure for consumer humanoid robots remains sparse. Most buyers didn't fully consider these ongoing ownership costs when making purchase decisions. Does the $1,499 price point make these robots truly accessible? For middle-class consumers in urban China, yes. For lower-income populations, it's still a significant expense that competes with more practical purchases. In developing markets, the price remains prohibitive. The robots are accessible in the sense that they're no longer exclusively for the wealthy, but they're not yet affordable for mass market penetration across all economic levels. Companion robots and social impact. The emergence of affordable companion robots intersects with profound social changes, particularly around loneliness and social isolation. Studies consistently show rising rates of loneliness across developed nations. In Japan, over 1 million people live as hikikomori, extreme social recluses. South Korea faces similar issues with its aging population. China's rapid urbanization displaced traditional family structures, leaving millions of elderly people living far from children who migrated for work. Companion robots enter this landscape as a technological response to a social problem. But can artificial companionship address real human needs? Research shows mixed results. Some studies indicate that elderly individuals do form attachments to robotic companions, experiencing reduced feelings of loneliness and improved mood. The key seems to be managing expectations. When users understand the robot's limitations and view it as a helpful tool rather than a human substitute, satisfaction increases. The psychological mechanism isn't mysterious. Humans are remarkably willing to anthropomorphize objects. We name our cars, talk to plants, and feel affection for stuffed animals. A humanoid robot that responds to our voice, remembers our name, and simulates emotional reactions triggers similar psychological responses. It's not replacing human relationships, but occupying a different category, similar to pets. Nobody claims dogs replace human friendship, yet the human-animal bond provides genuine emotional benefits. Robots might fill a comparable niche. Cultural acceptance varies dramatically. Japan has a long history of friendly robot characters in popular culture, creating social comfort with humanoid machines. Japanese culture generally views robots as helpful rather than threatening. Chinese culture traditionally emphasizes technology as progress, creating openness to robotic companions, especially for practical purposes like elder care. Western cultures show more ambivalence, influenced by science fiction narratives about robot dangers and philosophical traditions that sharply distinguish human from machine. Ethical considerations multiply as these robots become more sophisticated. If a robot is programmed to create emotional dependency, is that manipulation? Should there be regulations governing how emotionally persuasive AI companions can be? What happens to human social skills if people spend more time with accommodating robots than challenging real humans? For elderly users with cognitive decline, could realistic robots cause confusion about what's real? The impact on human relationships remains uncertain. Some psychologists worry that artificial companions might reduce motivation to maintain difficult human relationships. Why deal with a disagreeable family member when your robot provides unconditional positive interaction? Others argue that people maintain clear distinctions between artificial and real relationships, and that robots might actually encourage social connection by reducing social anxiety through practice interactions. What's clear is that affordable humanoid robots are creating new forms of human-technology relationship. Whether that improves human well-being or creates new problems depends largely on how thoughtfully we integrate these machines into social contexts. The technology has arrived faster than our social and ethical frameworks for managing it. What comes next? The $1,499 robot represents just the beginning of what's possible in affordable humanoid robotics. Several developments will shape the next generation of consumer robots. First, expect continued price reductions. As production scales up and component costs decrease, prices could drop to $800 or $1,000 within 3 to 5 years. This would move humanoid robots firmly into mass-market affordability, comparable to major appliances. Capabilities will expand significantly. AI improvements, particularly in large language models, will enable much more sophisticated conversation. Robots will understand context better, remember longer interaction histories, and respond more naturally. Current robots feel scripted because they essentially are. Next-generation AI will make interactions feel genuinely conversational. Physical capabilities will improve as motor technology advances and balance algorithms become more sophisticated. Expect robots that can navigate stairs, handle objects with greater dexterity, and move more fluidly. Battery technology represents a critical bottleneck. Current lithium-ion batteries limit operation time and add significant weight. Advances in solid-state batteries or other next-generation energy storage could double or triple operational time while reducing weight. This would transform practical usability, allowing robots to function throughout the day without constant recharging. Integration with smart home ecosystems will deepen. Rather than standalone devices, future robots will serve as physical interfaces for comprehensive home automation. They'll control lights, appliances, security systems, and entertainment through voice commands and physical interaction. The robot becomes the central hub for digital home management, with the humanoid form making the interface more intuitive and accessible, especially for users uncomfortable with purely digital systems. Competition will intensify from multiple directions. Japanese companies like SoftBank and Honda continue developing their own humanoid platforms with different design philosophies and capabilities. South Korean conglomerates invest heavily in robotics, leveraging their expertise in electronics and manufacturing. American companies focus on specialized applications, particularly in industrial and commercial settings, but consumer products are inevitable. Tesla's Optimus robot, though currently more expensive, represents Silicon Valley's entry into humanoid robotics with ambitious capability targets. The timeline for mainstream adoption depends on how quickly robots demonstrate clear, practical value beyond novelty. If next-generation models genuinely solve problems like elder care monitoring, household organization, or child education support, adoption could accelerate rapidly. If they remain interesting but not essential, growth will be slower. The comparison point is smartphones. They became ubiquitous because they solved numerous practical problems in a single device. Humanoid robots need similar utility breakthrough moments. Realistic predictions suggest that within 10 years, humanoid robots priced under $1,000 with significantly improved capabilities will be available. Adoption rates will likely reach 5 to 10% of households in developed Asian markets, with slower uptake in Western countries. They won't replace human workers or relationships, but will occupy a new category of interactive technology, more present and physical than current AI assistants, but still clearly artificial. The affordable humanoid robot era has begun. What started as science fiction became research experiments, and then luxury products has now reached price points where ordinary people can bring these machines home. The technology isn't perfect, the capabilities are limited, but the trajectory is clear. Humanoid robots are transitioning from fantasy to reality, from laboratories to living rooms. That threshold matters more than any individual product. We're entering a future where artificial beings with human form share our physical spaces, interact with our families, and shape our daily routines. The $1,000 robot isn't the destination, it's the first step into a world we're still figuring out how to navigate.